In the name of Allah, in this lecture, I will provide a simple introduction to short-circuit current calculations in electrical power networks. Short-circuit calculations in any part of the power system follow a single principle: constructing an equivalent circuit for the fault condition and solving it to determine the currents and voltages in different parts of the network. However, the method used to construct the equivalent circuit depends on assumptions specific to the short circuit condition, which in turn are influenced by several factors that must be carefully considered. A correct solution to a short circuit problem requires the engineer to have a solid understanding of fundamental principles and concepts. Furthermore, a short circuit is a random event that can occur at any moment and at any point in the network. Since the location and timing of the short circuit affect the values of currents and voltages, obtaining precise and exact values for these quantities becomes impractical and unrealistic. This highlights the critical importance of making appropriate assumptions to achieve results that best represent real-world conditions. We would like to begin by noting that although there are many software programs available for short-circuit analysis, their usefulness becomes particularly evident in interconnected transmission networks, where relying on manual calculations is impractical. However, the situation is different for distribution and industrial networks, as the vast majority of these networks are designed in a radial configuration without closed or interconnected loops, making manual calculations practically straightforward. Moreover, industrial networks are significantly smaller than transmission networks in terms of the number of lines and busbars. Additionally, manual calculations greatly aid in understanding and interpreting what happens in the network during a short circuit. Therefore, this course will focus exclusively on manual solutions for industrial networks. Thank you for your attention. See you in the next lecture.